So I think this is a circuit. Hmm, Okay, so this is a circuit. So what is the equation of this circuit? Transfer function of this circuit is yes. What is the transfer function of this circuit? How we solve this transfer function of this circuit? Question number one.
V naught upon Vi equal to
सर पहले थर्ड स्टेज का निकालेंगे ना।
किसका?
सर पहले थर्ड स्टेज एम्पलीफायर का निकालेंगे ना।
या पहले कंप्लीट निकालेंगे.
ओके
So what is V naught upon Vi?
-1 upon 1 plus SRC2
-1 upon 1 plus SRC2 plus
S
S
square R
square
has.
R1 R2 C1 C2.
Yes, sir.
So basically R square C1 C2.
R square.
C1. Okay.
सर
Now, yeah,
सर ये याद करना पड़ेगा क्या या फिर ड्राइव करना पड़ेगा ये पूरा या डायरेक्ट कर
you
सकते हैं?
can you can drive also.
अगर डायरेक्ट कर दिया क्विज में तो ये इतना
आप रख सकते हो ये वाला फॉर्मूला यूज कर सकते हो डायरेक्टली. अगर आपने ट्रांसफर फंक्शन नहीं पूछा तो आप डायरेक्टली इसको यूज कर सकते हो. अगर आपने ट्रांसफर फंक्शन पूछा तो आपको ड्राइव करना पड़ेगा.
एंड सर एक और क्वेश्चन था। लेट से कोई क्वेश्चन 6 नंबर का है, हमने उसको ड्राइव कर दिया, सब कर दिया, बट फाइनल आंसर गलत आ गया तो उसमें 5 मार्क्स मिलेंगे?
5 नहीं पता, लेकिन स्टेप मार्किंग मिलेगी. स्टेप मार्किंग के अकॉर्डिंग जहां तक सही होगा उसके अकॉर्डिंग मार्क्स मिलेंगे.
मतलब सारा सही है, बस वो लास्ट वाला पार्ट गड़बड़ हो गया,
अगर
आंसर छोड़
लास्ट
दिया
आंसर
हमने।
गलत है तो जो आंसर के मार्क्स होंगे वो कट जाएंगे.
मतलब 1-1.5 मार्क्स कट जाएगा ना।
हाँ, 1.5 मार्क्स आपका कट जाएगा. अगर
ओके
आंसर भी गलत है और स्टेप्स भी गलत है कुछ, तो फिर उसके अकॉर्डिंग मिलेंगे. अगर पूरे ही स्टेप्स गलत है तो उसके अकॉर्डिंग मार्क्स मिलेंगे.
ओके सर, ओके, थैंक यू।
Okay, so V naught upon Vi is equal to -1 upon SRC2 plus S square R square plus C1 C2. S square R square C1 C2. Now you have to calculate a V naught 2 upon Vi. So what is the relation between V naught and V naught 2? So if we are talking about the V naught 2 is the input with the of the integrator and V naught is the output. So V naught is nothing but V naught 2 upon with minus sign R C2 S. Okay, RC2S. Now, if I put the value of V naught here, so it is a minus V naught 2 upon RC2S is what? Minus 1 upon 1 plus SRC2 plus S square R square C1 C2. Okay, so the V naught 2 is what? 1 upon, sorry, S RC2 upon 1 plus SRC2 plus S square R square C1 C2. Okay, so V naught 2 is equal to V naught 2 upon Vi, sorry, V naught 2 upon Vi. V naught 2 upon Vi. So if I calculate the magnitude of this one, so it becomes a RC2 upon 1 minus omega square R square C1 C2 whole square plus omega R C2 whole square and root of it. Okay, RC2 upon the real component is what? From this one, if I put S equal to j omega, so it is a SRC2 upon 1 minus omega square R square C1 C2 plus j omega RC2. Okay, so sorry, S j omega. Now the numerator part is the omega RC2 and denominator part is the real component square plus imaginary component square and root of this one. So this is the value of V naught 2 upon Vi. Now R is given, C2 is given and omega is given. For the omega F is 2 kilowatt, 2 megahertz. Okay, F is 2 megahertz. Now can you solve this one and calculate the value of V naught 2 upon Vi?
Yes, after calculating this, the value is getting 2.00 something.
2.00 something. Okay. Hmm, you can calculate. Let me check. According to me, the value is around. According to my calculation, maybe possible I was wrong. According to my calculation, the value is around 007. Okay. According to my calculation, when I put a omega is equal to 2 megahertz, I am getting the V naught 2 upon Vi is equal to 0.007. Okay, I will recheck this one. I will recheck this particularly value. What is the value? It is a 0.007. Okay, so you know the formula. What is the V naught 2 upon Vi? Again, now it is a part of calculation. Maybe I was wrong. I am not sure. Maybe I was wrong, but I am getting this value. Okay. Yes.
Yes, sir.
Now, what is the relation between V02 and V01? If you see that V02 is nothing but
minus V01.
V02 is equal to minus R by R. Okay, because it is a inverting amplifier where the feedback circuit, feedback resistance is R and the input resistance is also R. Both are will be R times V01. Okay, so we say that V02 is equal to minus V01.
Sir,
Yeah.
for the proof of this above circuit, we have to first directly go through V in minus V out. V out equal to minus in R parallel C1.
Yeah.
V not upon Y. Transfer function is directly come from there.
Yeah.
R parallel C1.
Basically, what we do that is that we are considering that all current will be passing from this operational amplifier outside.
Okay, sir.
Okay. If the current will be passing from the operation amplifier, so V not one is 0.
Yes, sir. And V not
Okay.
2 is V.
If V not one is 0, V not two is 0. So basically, this circuit is as a short circuit, no voltage drop. So we have to find out the V in and V out.
Okay, sir.
Any other doubts with this?
No, sir.
Okay. Any other doubt in the other questions?
Sir, I'm solving the previous term paper. One
Hmm.
question, there two-stage forward amplifier question. How to solve that particular question, sir?
Uh,
It was in the previous term paper of quiz
previous
2.
quiz paper.
Yeah.
Wait. Question number?
2. For a
Okay.
two-stage forward amplifier, derive transfer
Yeah.
function and loop in.
Yeah. Mm, yes. I'm going to share my screen. Yeah. This question?
Yes, sir, this question.
Okay. So basically, what is the relation between V naught upon V2 and V naught? If V2 we are getting, okay, I multiply with V2 with 1 to get a V naught. This is a simple relation between the V2 and V naught.
Yeah.
Okay. Now we start with the starting. So we are getting a VI input, and with respect to this one, we are getting a V1 voltage. So what is the relation between V1 and VI? The
V1
GM1
by
is the current.
yeah.
GM1 is the current. That current will be going in two particularly part. Okay. So what is the current in this branch? GM1 VI into R1 upon R1 plus 1 by C1S. Apply the current division rule. Okay.
Yes, sir.
So current in opposite branch upon total impedance multiply by the current source is equal to the current in C1. So when the current will be going in this branch, so it will be divided in two parts because these are in parallel. So current in this branch, so basically the impedance of the other branch upon total impedance multiply by the overall current. Okay, so this is a basically we are saying that this is a current, not a VI upon V. This is the value of current I in C1. Now what is the voltage? V in C1 is I C1 multiplied by the impedance 1 by C1S. Okay, I multiplied by Z is V.
Yes, sir.
Okay, so what is the VC1 is I C1 multiplied by C1 upon C1S, and this VC1 is nothing but V1. So when I put a value of this one, so it V1 is equal to G M1 M1 VI into R1 upon R1 plus 1 by C1S multiply with 1 upon C1S. So you calculate the V1 upon VI. That is a G M1 R1 upon R1 plus 1 by C1S multiply by 1 by C1S. This is the value of V1 upon VI. Now this is the VI. Again we calculate the V2. So what is V2? V2, for calculating the V2, first of all calculate the current of IC2. So what is the current of the IC2 is if GM2 V1 is the current that is going in opposite branch impedance with the overall impedance R2 plus 1 by C2S. GM2 V1 into R2 upon 1 by R2 upon R2 1 plus C2S. Okay, so this is the IC2. Now what is the VC2? That is nothing but V2. So VC2 is what? GM2 into V1 multiplied by the R2 upon R2 plus 1 by C2S multiply with 1 upon C2S. Okay, this is the V2.
Yes, sir.
Okay, now we calculate the value of V1.
Yeah.
So we calculate the value of V1. Now put this V1 value in terms of V2. So we are getting a value of V1 and put this value here. So now the relation is V2 upon Vi. Okay. And what is the relation between V2 and V0 is? We know that V2 is nothing but, sorry, 1 times V2 is V0. So basically if the gain factor, multiplication factor, this particularly gain factor multiply by 1. Okay. If this gain factor multiply by 1 is, if this gain factor is 1, so we can say that V2 is equal to V0. Okay.
While calculating V1, sir, there is VI term also, na?
Yeah,
From there we can find the transfer function.
yeah, you can find the transfer. Okay, so you are getting a two equation. One is the V1 upon Vi. Second, you are getting the V2 upon V1. Okay, or you can multiply these two, so you will be getting the V2 by Vi. Okay. Now put the value of V2 by Vi as a V 0 by Vi. Why? Because V2 and V 0 both are equal. Clear?
Yes, sir.
Any other doubt? One student will be asking about the LED question also.
Yes, sir, it's for me.
Yes. Option D part.
Yes, sir.
Okay. Which color LED would be recommended using with this scheme if the variation of light intensity over the range of battery voltage is the primary concerns? Okay. So basically, if we see that when the battery voltage is higher, okay, when the basically current is higher, the intensity is higher. Okay.
Okay, sir.
Because it is mentioned that intensity is dependent on current. Intensity is dependent on current. Now, if current variation is high, if current variation is high, that means intensity variation is also high. Okay. And if current variation is high, so the battery consumption is high. Why? Because if required current is more, if required current is higher, maximum current, or we can say the maximum current or required current is higher, so the battery consumption is high. If battery consumption is high, so battery duration is less. Okay. So that means
Okay, sir.
we have to choose the option where the current variation is less, where the maximum current is less, so it will be long for a longer duration. Okay.
Okay, sir.
If in terms of intensity we are talking, intensity modulation we are talking, we are using particularly we are choosing the option where the current variation is maximized. But in the case of battery consumption, if we are talking, so we are using the option where the current consumption is less. Any other doubts?
Sir, can you just give the hint how to solve week 7 questions?
week 7 questions. Okay.
Yes, sir.
I will share the particularly solution of that with you till afternoon. Okay, some particularly modification is required, so I just do that one and then share it with you. But the thing is that this is my question. Okay, now what we have to do is we are taking this question. Now I have to do this question. Yes. Now what we have to do is we given that AS by U.
So in the exam, do we have to derive the whole equation then solve,
Yes,
or just
exactly. Exactly. You have to derive that particular equation because only the equation is important in this. There is no shortcut for that one. Okay. Yes. Is it clear?
yes, sir?
So we are using, like for example, we have a this voltage as a VA, this voltage as a VB. Mm, okay. This voltage is VB. Now what you have to do, if the current that is coming from this one, it will be going in this y direction because it is not going from this way. Okay. Now the current that is going from this one, it will be divided in two parts, R3 and R4. Okay, R3 and R4. So now the thing is that if the current is divided in R3 and R4, first thing is that R3 and R4 are in parallel or not.
Yeah,
Yes.
means I2 equal to I3 plus I4.
Why?
Current going
Okay,
from
the
R2
current
to,
current current is distributed in R3 and R4, so we can say
yeah,
the current in R3 and current in R4, the addition of this one is the current previous coming from that.
yeah,
Okay, but we can't say these two particular resistors are in parallel. Why? Because the one terminal of these two resistors is short at this point, but another terminal is not connected. Another terminal of R3 is connected with V0 and another terminal of R4 connected with the grounded. So if we assume that if V0 is a grounded, so we can say both are parallel. But actually these are not parallel. Why? Because these two are connected with two other terminals, different terminals. Okay. First thing you have to remember this thing. Second, if this is a non-ideal operation amplifier, so we can say the voltage V plus minus V minus. That is the VD voltage, V difference voltage here. Okay. If we multiply with the V difference voltage with A of S, we are getting a V0. if we multiply the difference voltage V plus minus of V minus with the gain, we are getting a output voltage. Okay, now V plus is what? 0 because it is connected with ground. So we can say A as 0 minus V no minus is equal to V. Or simply the equation is omega naught is minus A of S multiplied by the V minus. Okay, and what is the
And
V
V
minus
equal to
voltage?
VA.
VA. Now we have to apply the KCL. We have to apply the KCL. So if I say the current that is coming from this one, so VI minus VA upon R1 is equal to VA minus VB upon R2. Okay, and what is the KCL at this point? VB, so VA minus VB upon R2 is equal to VB minus V naught upon R3. Okay, the current that is coming in this way, it will be going to what? One is this one and one is this one. So VB minus V naught upon R3 plus VB minus 0 upon R4. Okay.
Yes, sir.
So we are getting a one equation this one equation this one. Now it is given a R1, R2, R3 is equal to R. So if I put the value here, so VA, V1, VI minus VA is equal to VA minus VB. So we are getting a VI is equal to 2VA minus VB. So this is the one part. Now if we solve the equation number 2, so VA minus VB upon R is equal to VB minus V naught upon R plus VB upon, now R4 is R by 4, so R and R cancel out. So VA is what? If I am taking this VB this side, so VB and 4 VB, that is the 6 VB minus V naught. Okay, so if I put this value here, so we are getting a VI minus VI is equal to 2 times of 6 VB minus V naught minus VB. So that is a 11 of VB minus 2 V naught. Okay, or we can do one thing is that here from here is that,
Put value of VA in minus
yeah, value of VA we are calculating from this equation number I just
1.
mentioned as equation number 4.
Yeah.
Okay, so we calculate the value of VA from the equation number 4 in terms of V naught and put it here. Okay, so now can you calculate it?
Yes, sir.
So this is the only way. Every question will be done in this way. Every question will be done in this way only. Now this question again the same. They are asking the transfer function. Okay, and find the DC gain. So what is the DC gain? When I calculate this value, so it is a first order. Okay, it is a first order. equation final, the equation is in this form: V naught upon Vi is equal to A naught 1 plus S upon omega I. So we have to finally take out this, particularly V naught upon Vi in this form. Is it clear?
Yes. Yes, sir.
Now what is the A naught? A naught is nothing but the DC gain. I'm not, I am mentioning the omega x, not omega u. Omega x is what? Bandwidth of closed loop. Okay, bandwidth of closed loop circuit. If we are talking about the bandwidth of open loop circuit, if we define what is the bandwidth of open loop circuit, so basically open loop circuit is this one because it is a op amp. Okay, it is a simple op amp without any circuit, so it is a open loop. And what is the bandwidth of this one is the omega u. That is the bandwidth. Okay, bandwidth of open loop. And when you solve this one, so it is the omega x. The value of omega x is different from the omega u. And this particular bandwidth is called the closed loop. Clear?
Yes, sir.
Any other doubts?
Sir, there is only one question from week 7, na? Week 7 and week 8. One question each.
One question from week 7, one question from week 8, and one question from week 5 and 6. Any other doubts? You can ask. Yes? No doubts? Hmm. Someone is writing now. Sir, you upload practice it for week 5 to 8. Okay, from week 5 to week 8. Hmm. Okay, 5 and 6 is prepared. So till afternoon, I will upload the week 5 and 6. Week 5 and week 6, I will upload it till afternoon. Week 7 and week 8, I will take time. So either by tonight or by the tomorrow morning, I will upload the week 7 and week 8 also. Okay, Kajal? Any other thing?
Sir, the mock will be the pattern of mock will be the same as the quiz 2 paper.
I have to check the mock. Uh, give me a second because I'm not sure about the mock. Yeah, you can say that it is all similar, somehow similar.
3 question each.
And the question in that one is the 4.
Okay, sir.
Any other doubts? No doubts? So, shall we stop here? I can't hear the voice. Rajdeep, are you talking anything?
No, sir.
Okay, okay. So, shall we stop here?
Yes, sir.
Thank you all.
Sir, today the mock will be uploaded, na?
Yeah, yeah.